Hello student, welcome and very good morning to you. Today I will be discussing a DPP on equilibrium of charge system. That is DPP 7 of electrostatic. And this DPP will be extremely helpful to those students who are preparing for NEET, main, advanced and wbjee. I hope you will understand this video. Please write a comment on it because this comment will be extremely helpful for me for your preparation in NEET, main and advanced. If this video is helpful for you, please like this video and write a comment on it because this comment is extremely helpful for me to make the next video for you. Question number 1. A charge q is placed at the center of a line joining two equal charge q. The system of the three charge will be in equilibrium if q is equal to. Look at this. This is the charge q. This is the charge q. And look at this. The small q charge placed at the midpoint between capital Q and small q. Okay. Now the three charges are in equilibrium. What will be the magnitude of q? Now for equilibrium capital Q, look at this. This charge repel along this direction by the force. Suppose this distance is 2r. So the repulsive force on this charge due to this is the K capital Q small q by r square. And repulsive force on this due to this charge, this is the K capital Q square by this is the 2r whole square. So net force on capital Q 0. So look at this K Q square by this is the 4r square plus K capital Q small q by r square equal to 0. So look at this. This is the this is the small q equal to this is the capital Q by 4. Look at this option. Look at this option 2 is correct. Okay. Now look at this. Three charges 4q, capital Q and Q are placed on the x-axis at x equals to 0, x equals to L by 2 and x equals to L respectively. The resultant force on small q will be 0 if capital Q equal to. Now look at this. This is the charge 4q. This is the charge capital Q and this is the charge small q. Now net force on small q 0. Look at this, the repulsive force by capital Q on small q. This equals to K capital Q small q divided by L by 2 whole square. No problem. Now, repulsive force on small q due to 4q charge, this is the, look at this is the K, this is the 4q into small q divided by L square. Now, sum of this force plus this force equal to 0 because they are directed in the same direction. So, look at this is the 4k q square by L square plus this is the 4q whole divided by L square into 4. So look at this here, capital Q is equal to minus small q. So look at this, option 1 is correct. Now look at this, question number 3. The two small spheres each having charge plus q are suspended by insulating thread of length L. This arrangement taken in space where there is no gravitational force, there is no gravitational effect. Then the angle between the two suspension and tension of each string will be. Look at this look at this in the gravitational field, the the angle between the two strings becomes 180 degree and distance between the two charge becomes L plus L. This is the 12. So tension T is equal to This is the repulsive force. So T equal to, this is the Q square by, this is the 4 pi epsilon naught 2L whole square. Look at this, option 1 is correct. Okay. Look at this question number 4. 3-point charges are placed at the corner of equilateral triangle. Assuming only electrostatic force are active, the system can never be in equilibrium. Yes, the three charges, when placed at the vertices of an equilateral triangle, the net force on a charge never be zero. Okay, so the system can never be in equilibrium. Okay, now question number 5. Two identical simple pendulum A and B are suspended from the same point. The bulbs are given a positive charges with A having more charge than B. They diverge and reach equilibrium with A and B, making an angle theta 1, theta 2 with the vertical respectively. Which of the following is correct? Okay, as the pendulums are identical, so their mass are equal, but they have different charge because electrostatic force on higher charge and less charge are equal. Here electrostatic force same, gravitational force same, so angle theta 1 and theta 2 are equal. Okay, understood? Now look at this question number 6. 2-point charges 9 E and plus E are kept 16 centimeter apart from each other. Where should the third charge Q be placed between them so that the system is in equilibrium? Now look at this. This is the 9E and this is the E. Now Q charge placed at a distance x from 9E. Okay, no problem. This is the 16 centimeter. So look at this. This is the 0.16 minus x. So look at this. The force on Q by 9E is same on force on Q by E. So look at this, Q into 9E into K divided by x square equal to K into Q into E divided by 0.16 minus x whole square. So look at this. This is the 3 by x the whole square equal to 1 by, this is the 0.16 minus x whole square. Okay. So look at this. This is the 3 by x equal to 1 by, this is the 0.16 minus x. So look at this. This is the minus 3x plus this is the 4 8 equal to x. Therefore, 4x equal to, this is the 0.48. So x equals to 0.1. So distance is the 12 centimeter from 9 charges. Okay. Now question number 7. Two charges 4E and E are at distance x apart. At what distance a charge Q must be placed from the E so that it will be equilibrium? So same problem as that in 6. So look at this. This is the, look at this. This is the 4E. This is the E. This is the charge Q. This distance will be R. Now total distance x, okay, we have to calculate R. So this is the x minus. Therefore, look at this, the force on Q by 4E, this is the 4E into Q into K by, this is the x minus R whole square, and this is the K into E into Q divided by, this is the R square. So look at this is the 2 divided by x minus R whole square equal to 1 by R whole square. Therefore, 2 divided by x minus R equal to 1 by R. So look at this. This is the 3R equal to x. Therefore, R equal to x by g. Look at this. Option 3 is correct. Question number 8. Look at this. Capital Q, capital Q, small q are placed at the corner of ABCD of a square respectively. Here, this is a square. Here, charge. Look at this. This is the capital Q. This is the small q. This is the capital Q. This is the small. Now, we have to calculate force on capital Q by three charges. Look at this. This Q charge repel capital Q charge along this direction. This Q charge repel this charge along this direction. And this Q charge repel this Q charge along this direction. The resultant of these three forces are zero. So look at this. Suppose this force F, this force also F, and this is the F dash. This is the 45 degree. This also 45 degree. So net force zero. That means F dash plus this is the 2F cos 45 degree equal to 0. Now F dash equals to the minus 2F into 1 by root. Now, what is F dash? F dash is the KQ square divided by this is the root 2, suppose side R whole square. This equal to minus root 2 into this is the capital Q, small q by this is the R square. So look at this capital Q equal to minus 2 root 2. Look at this option 1 is correct. Look at this question number 9. A charge Q is placed at the center of the line joining two equal charges Q. The system of the three charges will be in equilibrium if Q will be 1/4 of capital Q and negative side. Look at this option correct. Look at this question number 7. Two small spherical ball each charge capital Q, that is the 10 microcoulomb, are suspended by two insulating thread of equal length 1 meter each. From point fixed on the ceiling, it is found that the equilibrium threads are separated by an angle 30 degrees, separated by an angle 60 degrees between them, shown in the figure. What is the tension in the thread? Look at this. If the angle between two string is 60 degree, so angle of each string with the vertical, this is the 30 degree. Okay, no problem. So this is the 30 degree. Now force on Q, look at this, the force on Q, this is the Coulombian force. Now Coulombian force, this is the 9 into 10 to the power, this is the 9 into 10 microcoulomb. Okay, so look at this is the 10 into 10 to the power minus 6, 10 into 10 to the power minus 6 by R square. Look at this, if this 60 degree, so this side equal to this side equal to this side. So look at this, this is the 1 square. Therefore, this is the 0.9 Newton is the magnitude of force. Now, what is the mg? Look at this. What is the mg? Look at this. What is the mg? Mg equal to mass into acceleration due to gravity. Look at this. This is the mg. Okay. Now look at this. This is the mg. Okay. Now tension T. So here, this upward tension along this direction, this is the T cos 30 degree. And along this direction, this is the T sin 30 degree. So look at this here, T sin 30 degree equal to this is the 0.9 sin theta half, T into half equal to 0.9 Newton. So T equal to 1.8. Okay, look at this. This option is correct. Many thanks for watching this video. This video will be extremely helpful to you for your preparation in NEET, Main, Advanced and WBJEE.